Hey everybody, continuing through Unit 12. Unit 12 is all about probability, and today is our 7th day inside of Unit 12. We're going to take a look at how to make predictions on different types of like data markers, so like on a box and whisker, a circle graph, and a bar chart, or a bar graph specifically for today. Okay, we might go ahead and do this for 2 days. Kind of depends on how the time in class goes. So part one, but this lesson we will cover all in one day. I might make another set of notes similar to it. Part one, let's make a prediction based on box and whisker plots. So we've been talking about box and whisker plots a lot. They're the ones that have, like, you remember the quartile one, the quartile two, which is the median, and they have the quartile three and the lows and the highs. Remember, every chunk we learned last lesson is 25% of the data group. So like if you have 40 people, there's 10 in each chunk. Or if you have, 12 people, there's 3 in each chunk. So this particular one is about ski jumping in the Olympics, I believe was the title of it when I stole it. So let's just take a look at it and identify some things. Please remember that this is the low or the minimum, and this is the high or the maximum. This is your quartile one, the middle of your first half, and quartile two, your median, and this is quartile three, the middle of your upper half. Every single chunk within here represents 25% of the jumps that have been recorded in this data set, how many ever that might be. All right, so it says the first question, let's read this thing. What is the median? Hopefully you can remember the median is your middle of your box and whisker, so it's 218, and this is probably measured in meters since we are jumping, and the Olympics usually will use meters. What is the interquartile range? So the interquartile range, please remember, is Q3. If you're like, boy, you've been doing this forever, I know, because I guarantee you those keystones, they're going to have a question about it. It's Q3 minus Q1. So in this particular case, it's 234, take away 202. So 234 take away 202 is a range of 32. So in other words, the middle 50% of people, the ranges of those middle 50%, the range is a 32 range. So they differ by 32 meters from the lowest of the middle 50% to the highest of them. If this box and whisker plot represented 200 people total, so 200 jumpers, how many people jumped between 178 and 202? So what I'm going to do is I'm going to highlight that for a minute between 178 and 202. So that's from here to here. Well, that's just one chunk. So this here represents 25% of people. So I'm going to teach you the way Miss Miles did with percentages. We're going to draw percentage problems as a proportion. We're going to do 100% on the bottom and 25% on the top. Always 100, and the 25 came from that. The total number of people was 200, so the total always goes on the bottom. And we're trying to figure out how many people jumped between those two. So the first thing we had to identify was that it was 25%. And then the second thing we had to identify is how to make our proportion. So from here on out, I'm going to change that color. We're going to cross multiply. So that makes 100x equals, and I'm going to grab a calculator because I don't feel like redoing my notes. 200 times 25 is 5,000. Divide by 100, and we have x equaling 50. So there would have been 50 jumpers that went between 178 meters and 202 meters. So that's how many people fit within those two jumps. I'm going to write between 178 and 202 meters. Now let's change it a little bit and let's let that data represent, instead of 200 people total, let's let the data represent, that should say data. Sorry, I'm going to actually, while I'm here at my computer, I'm going to change. Sorry, I'm not trying to waste your time, just also not trying to waste mine. Going to my notes, I'm going to make that say data. Oh, excuse me. All right, so the data represents now 500 skiers, so a different amount of people. How many of those 50 skiers jump between 218 and 270? So I need you to go to 218 to 270. Let's erase our old highlight. And so 218 starts here and 270 goes here. Well, that is 2 chunks. I'm going to write 2 chunks. So that's 50% because every chunk is 25. So then I'm going to go back to stuff you learned in chapter 2. We're going to do 50 over 100. I'm going to move that up so I have more room. And we have a total. This time we're going to pretend that it represented 5 skiers. So how many people fit in that category? So we will cross multiply to get 100x equals 50 times 500, 25,000, divide by 100, and x would equal 250 people or skiers. And that's how many skiers jumped between 218 and 270 meters. Okay, now it says, in what 25% is the most spread out and what is the spread? So what we need to go is we need to take a look, where does this data seem to be the widest? So are we the most differentiated there? It's pretty big. Well, it's definitely bigger than here. So so far the lower 25%, and it's also definitely bigger than here. But this one looks pretty big too. So it's either between 178 and 202, 178 to 202, or let's see, 234 to 270, because those are my bigger parts of my box and whisker plots. Like if you're looking for like how spread out they are, you're looking like for how wide they are. I'm pretty sure it's the second one, but we're going to do some subtraction to double check. So 202 take away 178 is a difference of 24. So that's the spread up there for the lower half. And 270 take away 234, that's a spread of 36. So definitely this 25% between those two, not this one, it was a 36 meter spread. So it says, what was the spread? 36, that's the greatest spread, and it happened between that many meters of a jump. So people who jumped between 234 to 270, those people were the most spread out, that 25% chunk. If the box and whisker plot represented 320 people, how many people jump between 178 and 234? So I'm going to go up here. I'm going to look from 178 to 234. 178 to 234. So that's between here and here. That is 3 chunks of my box and whisker. So I'm going to write 3 chunks. So that is 325. So it's 25, 25, 25. So 75. So 25, 25, 25. So 75. And now I'm going to do the proportion that you learned in the previous classes. So 75% out of 100%, 320 people instead, and we want to know how many people fit within that range. So we're going to do some cross multiplication. So we'll do that, and then we'll do that. 100x equals 320 times 75, so 24,000. Divide by 100, divide by 100. X equals 240 if you divide by 100. So we can say 240 skiers fit between the 178 meter mark and the 234 meter mark if there was 320 total. Okay, so that's box and whiskers. Let's move on to circle graphs. So this circle graph, we have different movie types that people have been asked about. Let's look at our categories. We have sci-fi, drama, romance, comedy, and action. Okay, and they actually give you the numbers. So we could do the percentages or we could do the number of people. I'm trying to think what they'll give you on the keystones. Who knows what they'll give you? So you can either use 100% because they gave you the percentages. Like if you add them up, take a look. If I do 20% plus 20% plus 25% plus 30% plus 5%, and I'm getting those from here, 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 and here, that's 100%. Or you could just do like how many people they asked. So 4, 4, 5, 6, and 1. 4, 4, 5, 6, and 1. So they asked 20 people, and that represents 100% total. All right, so now what we're going to do is they're going to say if, that shouldn't say peoples, that should say people. I'm going to fix that on my end over here too. If the circle graph represents 460 people, how many people chose action as their favorite movie type? So let's go ahead and take this circle graph and apply it to 460 people instead. So here's what we're going to do. We're going to look at action, and I see that action is 25%. Take a look right there. So I'm going to make a proportion. I'm going to do 25% out of 100%. We're going to pretend like instead it represents 460 people. And we want to know how many people out of 460 would pick action. So that's going to be cross multiply 100x equals 460 times 25. So 11500, 11,500 divided by 100. And we can say x represents 115 people. And that's how many people would choose action if there were 460 people. I know this one only represented 20 people, but it's like if you take those results and apply it to 460 people, then we can go ahead and predict that 115 people out of those 460 would pick action. Let's do a circle graph now, but pretend it represents 200 people. It says how many more would choose comedy over drama. So here's what I'm going to do. I'm going to find comedy. Comedy is 20%. And drama was 5%. Okay, so that makes a difference of 15 percentage more who chose comedy. So I'm going to use this percentage instead. So I'm going to draw my proportion, 15% over 100%. Now we're going to represent 200 people, and we want to know how many people out of 200 would pick comedy over drama. So again, I subtracted the difference because I want comedy over drama, and then I made my proportion. So that's 100x equals 15 times 200, so 3,000, divide by 100. It's going to be 30, but if you want to look at the calculator to see it, you can see we get 30 people. Now let's say what in the world we just solved for. 30 people would choose comedy over drama. Okay, so we're changing percentages and then we're changing that into how many people. Now it's time for our bar graph. Okay, so people, I like this one. Nicest fruit. I like that was actually a question. Like, can you please tell me what do you think is the nicest fruit? Okay, anyway, I digress. So let's go ahead and see how many people were surveyed. It's always important with these ones that you figure that out. So this was not nice. I did this on purpose. I want you to go ahead and identify how many people picked apple, how many people picked oranges, how many people picked bananas, how many people pick kiwi fruit? And if you're one, I'm just doing this. I'm just eyeing it up, okay? So I'm just like making sure that I know how many people picked each, okay? That's what I'm doing there. And then how many people picked blueberries? I think that one's your tallest one. Really, people picked blueberries. I'm surprised. I would think that, oh, strawberries not on there. And then there are only 5. Grapes. Grapes are excellent. What's wrong with people? Grapes is the best. I would absolutely probably pick a. No, I don't even know what I pick. Okay, focus. Let's add those together to figure out how many total. 35, add 30, add 10, add 25, add 40, add 5. Just double checking. I got them all in there. Yes. So it looks like there were 145 people who were surveyed on this one. That's a lot of people to ask about fruit. Using these results, okay, now this time I don't have a percent. I don't have a percent. That's fine. It's going to be a proportion straight up. How many people can be expected to pick grapes if you surveyed 500 people? So here's our prediction, okay? We're not going to be doing over 100 anymore, because we're not given a percentage, okay? So we're just going to leave that to the side and show no, we can't do that. Instead, what we do is we find how many people did pick grapes. So how many people did pick grapes? Well, 5. Out of how many? 145. That's what we'll use instead. So I'm going to say how many people out of 500 will pick grapes. So I set that equal to how many people actually did pick grapes. So this is what you are predicting. This is the information that you have. All right, so you're using what you have to predict the future. So I should do this in purple since it's about grapes. And I should do it in a real color of a grape. All right, so that's going to be 145x. And then 5 times 500, if you're not sure, is 2,500 or 2,500. Divide by 145. And I have approximately 167 people who would pick grapes. Why does that not look right? Why does that look like I didn't do that right? 5 out of 145. I think I did everything okay. I don't think I did anything wrong. I don't know why I don't believe it. I still don't believe it. I still think I did it wrong. I did do it wrong. Look at that calculator. I am not editing my video. Miss Langeli did not divide right. I'm like, that number seemed so high. Hopefully you're watching this video and you're like, she didn't type 145. She only typed 15. There we go. That seems so much better. Yeah, only 17 people are going to pick grapes. I was going to say that 166 seemed way too high because that was such a low number who picked grapes. Okay. Sorry, guys. If you didn't notice, I did divide by 15. I must have missed the 4 when I typed. Okay, so much better now. Now let's do this one. If 300 people were surveyed, so now we have a new survey out of 300 people. Oh, look at this one. How many more people would be expected to pick apples over oranges? So let's see. Apples was 35. Oranges was 30. So if I subtract that, I currently have 5 more people. This is my current. So again, I can't do the percentage thing. So my new fraction is going to look like this. So this is what I want to predict. This is what I have. So currently I have 5 people out of a total of 145. But I want to know how many people will I have out of 300. Proportions are such a beautiful thing. So I'll cross multiply here. So 145x equals 1,500. And if you're not sure, it's 5 times 300. Divide by 145. And again, this is our prediction. Oh dear. 1,500 divided by 145. They're not going to screw it up. So I can say essentially 10 more people would be predicted. I'm going to use the word predicted to pick. What am I picking? Apples, not just apples, but apples over oranges. Oranges. I even said it funny and I didn't spell it right. Okay, so if you're trying to pick one over the other, you need to make sure you do that subtraction thing. And if you don't have a percentage, you do it out of the total that you do have. Now we need some old Algebra 1 review about slope and y equals mx plus b. A water tank already contains 55 gallons. That's the y-intercept because we already have that much. And Baxter is going to fill it, so positive. Water flows into the tank at 8 gallons a minute. See that word per? There's your slope. So write a linear equation to represent this. So it's y equals 8x, 8 was my slope, plus 55. You should know that x represents how many minutes, and you should know that y represents the total amount of gallons. A video rental store charges $20 membership fee and $2.50 for each, there's your slope, video rented. So it's y equals my initial membership fee and my slope for each video. So x would represent how many videos and y would represent the total cost. A bus company took a tour bus on the ferry. 30 people were aboard. The ferry charged $180. That is not an initial fee. That is a point. The following week, 50 people cost $220. I see 2 points. I see 30 points being 180, and I see 50 people, I said points, I meant people, being 220. So this one is different. I only want the slope. I think getting y equals mx plus b might be too much, but the slope we can absolutely calculate. 180 minus 220, and that would be 30 minus 50. Now, if you so choose to do 220 minus 180 and 50 minus 30, that's fine, but you have to either do top minus bottom or bottom minus top and stay consistent. 180 minus 220 is negative 40. 30 minus 50 is negative 20. If you math enter that, you get a positive 2. Okay, so your slope is positive $2. And what is that going to be? It sounds like that is $2 for every one person that comes aboard. So there must be an initial cost, but that's how the slope works out. And I'm just going to double check my numbers. 180 minus 220 is certainly negative 40, negative 20. Yep, we're good. Ow, sorry. So the slope is $2. If you're interested, it's $2 per person, but there must be obviously an additional fee that we're not going to do right now. We can maybe talk about that part later. Okay, but that's how you find your slope. Hope this was helpful.